All right, so let's take a look at yesterday's lab that you hopefully were able to get through all right. I don't really know that the lab versus the intro makes much of a difference. I think it's all basically the same. Maybe where some things are at are a little bit different. But anyway, if we go to build, the one that was probably kind of tough, the first one that was kind of tough, where they gave you 1 bulb, 2 bulbs, and 3 bulbs. If we look at those like so, right? And then we attach our wires. Now I need to have the wires, remember, attached to either side. And then we can go like this, right? And we see that. Now this one, I need to connect these two. It doesn't matter what order I build the wires in, but I needed to connect those two so that the electrons have to go through both of those, right? And so if you were having trouble with yours yesterday, hopefully this helps. You see how I'm kind of connecting those so it goes one light bulb after the next. And then once they snap into place, it's pretty nice for I can move it around as a group. And right, we can see that, right? So right off the bat, one of the first things it asks you is, what do you notice about the bulb? Be descriptive. Well, the electrons are moving pretty quick here comparatively, slower here and really slow here. This one shows pretty bright. This one shows not so bright. This one shows barely lit up at all. We see that same thing when we build them in real life. The light bulbs are just less bright when we have more of them. So if we go to use our ammeters, the float ammeter is a little, oh no, not that ammeter. I don't like that ammeter. Go away, this ammeter. Yeah, trash you? Yeah, there we go. This ammeter is really easy to use. I can just take it and float it over things. So this second one here, 0.45 amps, 0.45 amps, 0.45 amps, 0.45 amps, 0.45 amps. Hey, look at that. It's 0.45 amps everywhere, right? This is in series, and everywhere in series, it is the same current. Oh, that's a different current. And that makes sense because we said current was flow of electrons. And these electrons certainly look like they're flowing different than these. They're flowing a little faster. This is 0.9 amps, 0.9 amps, 0.9 amps, 0.9 amps, 0.9 amps. And then we look at the one with 3 bulbs and 0.3 amps, 0.3 amps, 0.3 amps, 0.3 amps, 0.3 amps, 0.3 amps. That is a nice mathematical relationship. 0.9, 0.45, 0.3. You're like, well, it didn't cut in half each time. No, it didn't cut in half each time because we didn't double the number of bulbs each time. We went 1, 2, 3. So it went 0.9 to 0.45 to 0.3, right? You might start seeing the relationship there a little bit from what's going on with the resistance. If we, instead of putting these in series, if we put them in parallel, I'm just going to delete these and just compare the 3 sets. So now I've got 3. Can I grab this whole thing at once? No, you just go over here. So you're out of the way. Hide behind Mr. Fredrickson. Here we go. So we're going to take 3 bulbs, and now we're going to put them in parallel. So the book did it like this, or not the book, the little worksheet. Oh, look at that. It spins around while I'm doing that. That's weird. Stop twisting. I don't want you to twist. There you go. So here we're going to go, wait, no, not from 1 bulb to the, how do we want to do that? So we build each one as its own, yeah, that's right. Each one is its own little series here, right? So this guy goes, and what you'll notice about this one is this one's going to go on its own too. So I could build it straight from the battery up here, or I could build it here where we're bypassing that battery. Either of those ways works. I'll kind of move some stuff to the side so you can see how things are attached here in a second, right? But so for this top one, I went ahead and went from the same side of this bulb to the same side there and back. So those electrons, if you look here, maybe if we move it, yeah, there we go. We can kind of see each one of those is kind of its own little path, so to speak, right? So when we look at those, we can see that. If we check our currents, 0.9, 0.9, here it's 1.8 because they're sharing that wire, but here it's 0.9, and here it's 0.9. And here it's 0.9. So because this wire is getting shared by these top two, since I didn't go directly to it, I kind of piggybacked right there, it's 0.9. But each of the bulbs specifically is in their own wire. So there you have a Y split going on right here where some of them are going up to this bulb and some of them are going over to this one. But But we see when they're in parallel, we don't see a voltage drop, but you will see, look at the battery. The battery is going to get used up real quick here. It's 0.9, 0.9, 0.9, right? So all three of those 0.9s added together for that one. So we see a little difference there. Let me think, are there anything else on these that are going to be pretty tough? Where they just wanted you to check voltage. Oh yeah, let's check some voltages and stuff here. So we'll get rid of our ammeter, get rid of our ammeter, get rid of our ammeter. Okay, we are going to slide our ammeter out of the way because I don't care about it. The voltmeter, we have to kind of hook up. So if I look at my voltmeter, I see in this parallel one, 9 volts across my battery. So then across this bulb, it is 9 volts. If I check the wire, it's like none. Now in real life, the wire is using some of that voltage, but these are all idealized, right? So 9 volts on that one, and 9 volts on this one, and 9, I should measure it before I say it, 9 volts on this one, right? So all 3 of those bulbs got to use all of the 9 volts. If we look at our series one over here, you might, when you compare the look of them, you might say, well, those voltages probably aren't the same because those brightness, the brightness of the bulb is not the same. So this one is 3 volts. Now it says 6 volts right now, but if you look, I'm actually measuring across 2 light bulbs there. If I go over to here, it's 3 volts again. If I go down to this last bulb, it is 3 volts again. If I go across all 3 bulbs, it's a total of 9 volts. And if I go across my battery, it is 9 volts. So here in this one, they're sharing the voltage, 3, 3, 3. If we added a fourth, it'd be what's 9 divided by 4? I don't know. Brain's not working right now. 9/4 for each one of them. We'll just leave it as a fraction. Whereas this one would still get all 9 volts. But then your current would be a lot more through your battery. And that's how you can start catching things on fire and like melting your fuses like we talked about the other day and that kind of stuff. Right. So that is the one for yesterday. We'll put up a new one to try and tinker with those a little bit today. If you are having trouble with these, and you're like, I'm not confident in the answers I'm putting on my worksheet, feel free to jump into the Google Meet and we can, look at stuff together. But I don't just want it to be a thing where you're watching me do it. So I'm going to try and address what I was asking you to do in the lab the next day. And I think we'll probably end up doing these for a couple of days. Anyway, hopefully today's works okay. Hopefully yesterday's works okay. Have a good weekend.